Welcome to this latest podcast. My name is Javier Solsona, and I'll be showing you how to use a reverse foot setup. Pretty common setup, but what often happens is that when we use our rolls and our toe twist, what happens is our controller gets off our axis, and that can often be a problem for animators. They would like this to follow with or at least be at the same position with the ankle. So what we'll do is through a bit of meld scripting, we'll be able to show how we can reset this position of your controller to where the ankle position is. So for that, first of all, let's look at our reverse foot lock setup. It's pretty straightforward. We got our knee here, ankle and bones, so that's straight foot here, nothing new. And then we got our reverse foot, which is the red one, started with a controller, and then going back to the ankle, goes back to the heel, toes, ball, and then back to the ankle again, hence why reverse foot. Now we have an IK handle here and IK handle here. Those are straight chains, single chains. So, and we got another one going from the thigh all the way to the ankle. So that way we can control our knee here, and we also can have our control over the toes and the end part of our foot. Now these toes here, what we're doing is with our IK handle at the end. There it is. If we move and we group it to a controller that is just before that, in a bone before, we're pretty much changing the axis, where the axis point, rotation point is. Right now there's a connection to it. That's through our tap. That's what we're controlling. So that's why it's locked. So that's our setup. Now, to add a little bit extra, and this is where the reset comes in, we're going to have two more controllers. Now, there are locators here, and what we've done is add one that is just straight from the axis. So our controller is aiming straight towards this, and we'll use this as our aim too when we go through our reset. And then we also need another one that we're going to be using as an up vector. If we don't have this, when we do an aim, then we won't be able to match things if they are in an off axis like this. So let's go and see what we can do with our setup here. Let's add a very quick animation. We've got set a key here, and then let's even move our controller. And let's not worry about the tap first. We're gonna do a roll and even another one a little more to the foot. So we got our animation doing that. Now what we'd like to do is be able to move this to this point here. So our script is called ResetFoot, and we're just gonna call ResetFoot here, ResetFoot. And if we run this, I'm gonna run it on a key after. What we've done is we're moving all the controller back to there, and then we're adding a bit of tap. So if we go back and forth between the 2 points, you can see they're exactly the same. But even though the foot hasn't moved, our controller moves. And now this is a lot friendly now for animators, especially when they're doing like a walk cycle, where if they're trying to reset while they're moving the foot, it becomes pretty cumbersome and pretty hard to follow what your curves are doing. Of course, we can do these kind of resets over a few frames. We can do that. So now we can have our foot reset. So let's look at how we're doing this. On 11 it's a little bit easier, since we can just see it's straight away what happens. So let's go to our code here and our ResetFoot. First of all, what we're looking into is the current frame. So in our case, we were on frame 11, so it would pick that up. And then we need to create quite a few temporary transform nodes. So I'm not even giving them a name in this case because we know we're going to be deleting them, but I am assigning it to a variable. So I create a controller, and then what I do is I do a parent constraint to the ankle. I'm hard coding all the names here, but they can be used any technique that you like to use, using messages or whatever might be your pipeline works. For just to show the example, it's a lot easier if I just do a few hardcode names. So what we're doing is we're aligning the ankle temp, the transform node that we just created, to the ankle. So we got our ankle here, and we align it by doing a parent constraint, and we delete it right away. So what we're doing is creating a transform node that will sit here, aligned even with position and rotation. We are also creating another temporary location, another temporary node, which we're using as our aim. So that's going to be this controller here. We're putting another controller right on top of that, and we're going to be using another one right towards the aim. Now we do this, the aim vector and the up vector. Now we do this because we need to be able to set these positions up, because afterwards we're going to be moving this to that position. As soon as we move that, we lose this position, and we want it still to be on these areas here. So once we got our temporal position for all our nodes, we need to figure out what the rotation, Z rotation of our ball joint is. Now this is our ball joint here, and because we've got in our outliner here, we've got our tap controller, this is it, it's on the same position. We are really sharing the rotation, so the rotation of this bone here ends up being the same rotation that we want for our IK handle off pivot point, which is up here on the same as the ball. Now for that, we're controlling this through the tap in our controller. So basically what we want to do is this angle here is the same as the tap. So that's why we're recording it, and then we'll apply later on. So this is going to be our tap value, and we get the rotation of our ball joint. Now once we have that, what we do is we move our foot IK, that's our controller, it's called foot IK, our foot IK, we move that to the same position as our ankle temp. Now as soon as we move that, we just did, as soon as we do that, then all our, let's close that, everything else moves. So that's why we wanted to have those extra controllers here. So we just do a move, and now we do the aim. Now here's the important one. We're doing an aim with no offset, the weight of 1. Now the aim vector, we know it's going to be Z, and it's a positive Z. That's our angle that we're looking into here. So that one, and we want to aiming towards this object here. So object up is the walled up type is an object, and the object that we're the object that we're aiming to is up here. That's our format, and the object up type it's an up vector, up temp, which we have recorded previously as an up vector here, which is this object here. Once we have that, because now it's aiming, what we just did is moving like this and then aiming it to our positions there. So we just did that, and then we still got all these extra values. What we really want to do is just zero everything out, and then that's why we had recorded the rotation. We just add that to our tab. So we do that here. We set all our values to 0. We set the tab value to the tab value we just recorded. In our case, we had to actually multiply by -1. And then after that, we just set keys for all our controllers. Once we have done that, we delete all our temporary controllers that we had, all temporary transform nodes that we have created, and that's it. We get back our foot in exactly the same position, but now our controller is sitting perfectly in the same place as our ankle is. That's it for this podcast, and I hope to see you soon.